The universe is vast and amazing. Black holes are some of its strangest wonders. For a long time, they were just ideas, dark objects imagined by scientists. Now we know they are real, and we can even observe them. Imagine a place in space where gravity is so strong, nothing can escape, not even light. This is what a black hole is. It stretches our minds and challenges our understanding. Black holes are not just cosmic vacuum cleaners. They play a big role in shaping galaxies. They test Einstein's ideas about gravity and push physics to its limits. They are like cosmic laboratories, helping us learn about space and time. In this journey, we'll explore what black holes are, how they're born, and how we find them. We'll see how science triumphed by capturing the first ever picture, and we'll look at the mysteries that still wait for us. Come, let the universe astound you. Black holes are more than just empty space. They are key to understanding the cosmos. Their existence was once doubted, but now they are proven. Observing them has changed our view of the universe. They are places where the known laws of physics break down. Black holes challenge our imagination and our science. They are the ultimate cosmic enigmas. Let's dive into their mysteries together. The journey will take us to the edge of what we know. Prepare to be amazed by what lies beyond. The universe is ready to reveal its secrets. Stars are born, they live, then they die. Our sun is a star, but it won't become a black hole. Only the most massive stars can do it, those much bigger than our sun. These giants burn through their fuel quickly and die young. When their fuel runs out, gravity takes over. The star's core collapses in a violent explosion, a supernova. The outer layers blast into space, creating colorful clouds. But the inner core keeps collapsing. If it's massive enough, more than about 3 times our sun's mass, nothing can stop it. It squeezes down smaller and smaller into an infinitely tiny, dense point, a singularity. And just like that, a black hole is born. Not all stars end this way. Smaller stars, like our sun, become white dwarfs. But for the biggest stars, gravity wins completely. The process is one of the most dramatic in the universe. Supernovae light up galaxies, but the real story is at the core. The birth of a black hole marks the end of a star and the beginning of something new. These black holes can grow by swallowing more material. Some become monsters at the centers of galaxies. The cycle of star birth and death shapes the cosmos. Black holes are the ultimate fate for the most massive stars. Their creation is a cosmic transformation. From the ashes of a star, a new enigma emerges. The universe recycles its matter in spectacular ways. Black holes are both an end and a beginning. Their story is written in the stars. At the heart of every black hole lies a singularity. This is a point of infinite density, where all the mass is crushed into a single spot. Our laws of physics break down here. It's one of science's deepest mysteries. Surrounding the singularity is the event horizon, the point of no return. It's not a solid surface, but an invisible boundary. Once anything crosses this line, it can never escape, not even light. The size of the event horizon depends on the black hole's mass. For a black hole with the sun's mass, it's only about 3 kilometers across, but most stellar black holes are much larger. Crossing the event horizon is a one-way journey into darkness. Nothing can escape from inside, not even a beam of light. This is why black holes are black. They don't emit or reflect any light. They are the universe's ultimate traps. The event horizon marks the edge of the unknown. What happens inside remains a mystery. The singularity challenges everything we know about physics. Black holes force us to rethink space and time. They are places where the ordinary rules no longer apply. The event horizon is a cosmic boundary. It separates the known from the unknowable. Black holes are the most extreme objects in the universe. Their secrets are locked away beyond the event horizon. Scientists are still trying to unlock these mysteries. The singularity remains hidden, but its effects are felt across the cosmos. Black holes remind us how much we still have to learn. Black holes might seem complex, but in some ways they're simple. Scientists say they have no hair, just 3 defining features: mass, spin, and electric charge. Most black holes have almost no electric charge. The event horizon is the boundary of no escape. If a black hole spins fast, it creates an ergosphere, a region where space-time is dragged around. This ergosphere lies just outside the event horizon, like a swirling cosmic whirlpool. Many black holes are surrounded by material, gas, and dust from nearby stars. This material forms a spinning accretion disk around the black hole. The disk grows hotter and brighter as it spirals inward. Sometimes, not all material falls in. Some is blasted out as powerful jets. These jets shoot from the poles, perpendicular to the disk at nearly light speed. They can stretch for thousands of light years. The accretion disk and jets make black holes visible, even if the hole itself is dark. The energy released is immense. Black holes can outshine entire galaxies for a brief time. The features of a black hole are simple, but their effects are dramatic. Mass determines the size of the event horizon. Spin affects the shape of the ergosphere and the power of the jets. The accretion disk is a cosmic furnace. Jets are among the most powerful phenomena in the universe. Black holes are not just empty voids, they are engines of cosmic change. Their features help us detect and study them. The simplicity of black holes hides their true power. They are both simple and profound. Understanding their features helps us unlock their mysteries. Black holes are the universe's ultimate paradox. Black holes are invisible, but their effects are not. Astronomers look for the influence of their gravity on nearby stars and gas. If a star orbits something massive and unseen, it might be a black hole. We measure the star's speed and path to calculate the hidden mass. Another clue comes from X-rays. Material spiraling into a black hole gets incredibly hot and shines in X-rays. X-ray telescopes in orbit can spot this telltale sign. The X-rays come from superheated gas just outside the event horizon. It's like hearing a scream from matter being torn apart. These signals reveal the presence of a hungry black hole. Even though we can't see the black hole itself, we see its effects. Astronomers use these clues to find black holes across the universe. The hunt for black holes is a cosmic detective story. Einstein showed us that gravity can bend light. A black hole's gravity acts like a lens, bending light from distant objects. This effect, called gravitational lensing, creates cosmic telescopes. Sometimes a black hole passing in front of a star makes its light brighten or distort. We might see multiple images of a single galaxy. These strange sights can reveal a hidden black hole. There's also something even more profound: gravitational waves. When two black holes merge, they send out ripples in spacetime. In 2015, we detected these waves with LIGO and Virgo. This opened a new way to explore the universe. Now we can hear black holes colliding. Gravitational waves give us a whole new sense for cosmic events. Black holes reveal themselves in many ways. For decades, black holes were just ideas. Then we found them indirectly, but scientists wanted more. They wanted to see one. The Event Horizon Telescope, or EHT, took on this challenge. It's a network of radio telescopes across the globe, working together as one giant eye. Using a technique called very long baseline interferometry, they achieved incredible sharpness. In April 2019, the EHT team released the first direct image of a supermassive black hole in galaxy M87. We saw a dark shadow surrounded by a glowing ring of gas. This was a historic moment for science and humanity. The image confirmed decades of theory. It showed the event horizon bending light, just as predicted. The EHT's success opened a new era in astronomy. Now we can study black holes in detail. The universe revealed one of its greatest secrets. The image of M87's black hole was just the beginning. The EHT team also imaged Sagittarius A*, the black hole at our galaxy's center. Comparing them helps us learn more. But big questions remain. What happens at the Singularity? Our current theories can't explain it. We need a new, unified theory of physics. Stephen Hawking proposed that black holes slowly leak radiation. Hawking radiation. We haven't detected it yet, but it links black holes to heat and disorder. Black holes are key players in cosmic evolution. They teach us about extreme gravity and the growth of galaxies. The quest to understand them continues. Black holes push the frontiers of knowledge. The universe still holds many wonders. Each discovery brings new questions. The adventure is far from over.